All right, I'm excited to introduce our next speaker. Our next speaker is going to be Adam Lieberman, Head of Artificial Intelligence and Machine Learning at Finastra. He leads the data science teams that focus on using the latest emerging technologies to conceptualize and rapidly iterate on ideas and turn POCs into production-grade products and services. Adam joins us today to talk about concept drift, the different forms that it can take, statistical measures to quantify drift, and some of the mitigation strategies they've adopted to keep models healthy and serving great quality predictions. Please take it away, Adam.
Hello, everybody. My name is Adam Lieberman, and I'm the head of artificial intelligence and machine learning at Finastra. At Finastra, we build and deploy innovative next-generation technology on our open Fusion software, architecture, and cloud ecosystem. I work with our data science teams to develop and productize machine learning-based solutions across our many lines of business. When we deploy models in a production environment, there are so many obstacles and considerations we need to take into account. And once we get there, we think the fun is over, but the work does not stop. Today, I'm thrilled to discuss a key piece when it comes to monitoring models in production. A piece called drift that we need to be very aware of as we move from training models in notebooks to solutions running in the wild for our users and clients. In our session today, there are 6 core things that we'll cover. We'll start off with model deployment and what we need to consider to bring a model from a development environment like a Jupyter or Databricks notebook to a productized model running in the wild. We'll define drift and understand the different forms it takes, in particular a type called concept drift. We'll then touch on some statistical concepts to measure drift and some methods to combat it. Finally, we'll discuss the tool that my lab uses to monitor drift on our production models. Drift is a super important topic and something we must keep in mind. So with that said, let's jump right in. In our initial stage of model development, we focus most of our time on achieving the highest performing models based on our criteria for the task at hand, right? We want to develop a model for a problem and we need to get the highest performance. Really a model that solves the problem. Typically, our machine learning engineers work out of development environments like Jupyter Notebooks and Databricks environments and follow the machine learning pipeline we all know and love to produce an initial model file. However, we have to take this file and actually get it in the wild, in the hands of potentially millions of users seeking its predictions. When doing so, there are so many considerations and resources we have to think about. Latency, throughput, energy, model size, memory consumption, cost of our resources, and the devices we want to deploy our models on. Putting a model into a productized state is no small feat. And once we get it running, it does not mean the work's over. We need to constantly monitor these models in our production environment. We have to watch the predictions and inputs. We need to monitor model versions. We need to ensure operation, system, and environment stay up. And we have to watch things like dependencies, and there's so much more. The fun definitely doesn't stop once the model's in a productized state. And in this talk, we're going to focus on one specific monitoring piece, a piece called drift. So what is data drift? Data drift is defined as the change in the distribution of a baseline data set on which a model was trained and the current real-time production data that's coming in. To simplify this, it's a change in the way our data is distributed, the way it looks and feels, from the original training or baseline data set to the current real-time data that we're ingesting into our model. We can't always assume that the data we build our model on will forever have the same distribution. Things change, the world changes, people and item behavior changes, and this in turn changes data. We need to note that even after we have a model that has awesome performance, we need to watch the incoming data to see if and how its distribution is changing. Now, data drift is more about the properties of the independent variables in our data, not the label or the concept we're trying to predict. Concept drift is another form of drift where the statistical properties of the class variable or our label change over time, and so can the meaning of the concept or the way we define our label. For example, say we're detecting spam and our machine learning model finds that people who send more than 6 messages per hour are spammers. We make an update to the app and now people are a bit chattier and we have more users on the site. And we find that the common non-spammer is sending 10 messages per hour. Now the concept of a spammer has changed because before we said, people that send about 6 messages an hour, are spammers, and now it's pretty common for non-spammers to send more than 10 messages. In summary, concept drift is a change in the relation between the input and the concept or the output, or a change in the meaning of the concept. Let's look at a hypothetical example of drift that could occur in the real world. Let's pretend we're a bank that operates maybe in a less affluent area. Our usual customers are lower income and have particular spending habits. We offer a credit card and have a custom machine learning based risk model used to help assess creditworthiness. We take a whole bunch of data and we build an awesome model. We go through all of the machine learning engineering steps and deploy our model in the cloud. Over time, we notice a bunch of new data hitting our model and a lot of bad predictions being made. We do some internal research and we find out that the marketing team ran a very, very successful campaign. And now we have a very sizable customer base in an affluent area, say in New York. The data around these customers is much different than what we trained our model on. And as a result, the model has become a bit stale and the features hidden in our model are vastly different than the features derived from our usual customers. We also have a new type of customer that we had not assessed for risk before. This is a prime example of drift. We trained on data that we thought our customer base was like, but over time the data drifted and changed and started including data for types of customers we had not seen before. Data drift is real and can happen to any organization, and it's something we have to really look out for. Now, there are 4 core types of drift we commonly see. The first is concept drift, which we talked about in the prior slide, where there is a change in the distribution of our true labels given our model inputs. The second is prediction drift, where the predictions given our inputs, not the ground truth or our actual labels, changes in distribution. The third kind is label drift, where we see a label probability change. And the last is feature drift, where there's a change in the distribution of the model's input, the actual features. To make this a little bit more mathematically concise, let's let Y denote ground truths, Y hat denote a prediction, and X denote the model input with the probability formulation for each kind of drift in the pink circles. Now, drift and concept drift are very, very common, and I see concept drift a lot, so I want to spend a little bit more time on it and dive deeper. Within concept drift, there are a few different forms we see. There can be sudden drift, where all of a sudden, in a short period of time, a new concept appears. For example, when the pandemic hit, there was a huge increase in demand for cleaning products and hand sanitizer, right? Out of nowhere, everybody really tried to get their hands on hand sanitizer. Gradual drift is when a new concept phases in and gradually replaces an old concept. We can think of the days when flip phones were super popular. As smartphones came out, we started to see less and less manufacturers producing flip phones. There were a few flip phones being made every so often, and pretty much all manufacturers stopped their production. Incremental drift is an incremental change to a new concept. For example, we generally see the stock price change incrementally over time, right? It gradually increases or decreases. And no, GameStop would be sudden drift. And finally, we see reoccurring concepts where an old concept comes back after a new concept appears. Think of how bars are pretty quiet on the weekdays, Monday through Thursday, but get really busy on the weekend. Now, there are 2 overarching types of concept drift. Below in the center, we have some pink and purple data points separated by a function, a boundary that's classifying them. Virtual drift is when the features start to have a different distribution, but the model performance doesn't suffer. We see we have a similar dividing function, but the inputs, the pink and purple circles, have shifted to a different form, and they're located in a different spot on the graph. Real drift is another type where there's a change in performance. We see a change in the predictions given the inputs. Here we can see we have a whole different function separating the pink and purple circles. The line has completely changed and separated the boundary. To sum it up, virtual drift means the features look different, but the model is still working to some degree. Real drift is when the model performance actually changes. So why does drift occur? There are countless ways it can occur, and it really is impossible to provide a list of all the reasons why drift can happen. The world changes, people change, preference change, and thus data changes. For example, we might see drift because a competitor launches a product that steals some of a customer's base, or launches a new service in a region and they have a new type of customer they're getting data points around for. Customer preferences change all the time. There are constantly new trends and the likes and tastes of consumers constantly change. We might be recording data with devices that become faulty or corrupted and start providing inaccurate feature measurements. And there are also unforeseen black swan events like we've seen with the pandemic, which cause a dramatic shift in behavior. Drift can occur for many different and unknown reasons, and it's very important that we keep track of it. So, how can we keep track of drift from a statistical measurement point of view? Unfortunately, we don't have time to get into all the math behind these metrics, but here are a few different statistical metrics you can use to keep track of drift. We can leverage a KS test, we can use KL divergence, measure the population stability, or use Jensen-Shannon to name a few statistical measures around populations and data distributions. There are many other techniques like z-scores that can be utilized as well. If you're interested in keeping track of drift from a statistical measurement point of view, these are some pretty good measurements for your data science organization to check out and can really help quantify the meaning of drift. So why do we really need to keep track of drift? Well, models can become stale. They can potentially degrade in quality depending on their use case. On the left, we see a graph for model quality against time. This is a generic chart that shows over time as data drifts, models start to lose their performance. We need to leverage retraining to stay up to date with data and keep our performance high as shown in the right. Whenever we start to see a drop in performance as we monitor drift in many different forms, we can hit a retraining session to hopefully keep our models functioning well in the wild. But then we get into the question of how often should we retrain? There are multiple strategies for retraining and keeping models up to date to prevent staleness, data drift, and the performance issues that come along with it. The first option is to schedule cron jobs. Schedule set retraining sessions to refresh the model. Here we can leverage industry and domain experience around things like seasonality when we know data will start to shift. For example, maybe if we're building a credit card fraud model, we might want to get a retraining in around the holidays when we think users will start leveraging their credit cards a bit more. The next model or method is more of a threshold and level set method. Instead of setting concrete retraining sessions, we can monitor drift metrics as shown on the previous slides and trigger an automatic retraining only when we cross over a threshold. For example, we might use KL divergence to quantify drift. When our measure gets beyond a certain threshold, we might automatically fire off another round of retraining. Another great method is online learning. Here, certain learners can be incrementally updated as new data becomes available. Online learning allows algorithms to dynamically adapt to new patterns in the data. If this is interest to your team, scikit-learn supports many out-of-the-box estimators for classification, regression, and clustering in an incremental and online style. There are many other ways to deal with data drift, but these three are great strategies to keep in your back pocket depending on the use case. Now that we went through a brief primer on drift and began to understand what it is, what are its forms, how can we measure it, and how to combat it, let's talk about how we view drift at Finastra. At Finastra, we deploy models across many financial lines of business with many different use cases. We're building models in lending, payments, treasuries, capital markets, and across retail and corporate banking for hundreds of clients. With the scale we build and deploy at, it's very important for us to constantly monitor model performance. We make it a priority to register baseline and target data sets that we can analyze over time. We create monitors and alerts across different data metrics and look into why drift occurs when it happens. It also helps from a legal and governance perspective as we can see initial data sets and feature importances and how incoming real-time data has changed over time and impacted the models we build. Depending on our use case, we deal with drift in many ways. We leverage our business domain experts to discuss seasonal retraining. We have certain use cases where we train based on thresholds and look at a majority of the popular drift metrics. And online learning is always a fan favorite with us. Retraining is key in the financial space as we see data changing all the time. There are many tools and frameworks to help organizations monitor drift, and I really encourage machine learning teams to dive into drift and develop strategies and mitigation methods to ensure the models are protected and serve the needs of their users. And that's the primer on drift. Thank you all so much. If anyone has any questions or wants to dig deeper, please feel free to reach out to me at adam.lieberman@finastra.com. Thank you very much.
Wow, thank you, Adam. That was great. Very informative. We have some wonderful questions from the audience, so I'm just going to go ahead and dive in. The first one is, are there particular industries that are more prone to drift than others?
You know, drift can really happen to any industry. For example, in financial services, we see it happening on account level basis where, user behavior might change with, say, seasonality. In manufacturing, maybe we start changing the way a CPU looks, whether it's adding a sticker, changing the way the box looks, and maybe a model we developed for spotting defects starts to fail. We might have a weather model and a sensor might break, and it might be sending some faulty data. So really, drift is a universal problem and can really affect any industry. So it is very important that if you're building a machine learning model, agnostic to the industry and you're putting into production, you're constantly monitoring drift.
Awesome. The next one we have, are there cases where drift does not occur? And if so, do you have an example?
So I think you should always monitor for drift when it is a production model. But maybe to give an example, let's say we have and this will be a funny example, a very, very specific dog classifier. And we want to classify maybe Chihuahuas and Golden Retrievers. We can assume we have a very expansive set of data that we're training our model with, and maybe it's only using, the front-facing images of dogs, and our resolution is 256 by 256. Unless the images start changing and the dogs are not in frontal view, like maybe we start sending our model images of dogs from the side or kind of an aerial view, or even if maybe there might be, some poor lighting conditions that affect the image that's being sent to the model, the two dogs should look the same, hopefully, for the next 50 years. So I can safely say we're building a pretty generic model, unless, some kind of genetic changes start happening. So really, our training and validation and even our inference data should be the same. And I could say that's a pretty, generic model where, monitoring drift may not be as important. But like I mentioned, things can go wrong. We would still want to monitor drift because, for example, like I said, if the image quality starts to degrade, our models can start to have faulty predictions and degrading quality.
Great. Next, do you have an example of a model you're building and why you're monitoring drift?
Yeah, definitely. So we monitor drift on all models that we build. Being in the financial services sector across many different financial lines of business and deploying models for many different institutions, we have to ensure that our models are high functioning and don't degrade in quality when drift presents itself. So one model we're working on right now is for electronic statement adoption for e-statement users. We never know if a marketing campaign is run and there's an entire new segment of customers our model has no idea about, or what if there's a huge power outage in some area and digital activity starts to drop and the model predictions start to become incorrect. For our electronic statements model, we know that user behavior does change and there's many, many different reasons for it. So that's something that we monitor drift for to make sure we're prepared for it.
Great. And it looks like we've got one final question from the audience. Do you have an example of reoccurring drift you see in financial services?
Yeah, definitely. When we look at more transactional level data, on accounts, we often see reoccurring drift happen. If we look at the holidays, for example, we might see an uptick in spending, and when they die down, we see a little bit of a dip or a drop. And models that rely on data related to spending and transactions usually should be retrained as we go through these seasonal periods as our data does start to change. And I think, another example regarding financial product recommendation models, new financial products from our institutions are frequently added. So we do need to adjust these models for these new addition of these products.
Perfect. Let's see, we do have one more that just came in. Do you need drift detection even if we refrain frequently or online?
I would say it's good to keep track of the metrics around drift and, keep track of your predictions, even if you're doing, retraining frequently. A lot of times, we'll set our models on schedulers because we know that, hey, every month or 3 months, we do need to do retraining. But we still like to keep track of some of these statistical metrics, and even for online learning. But I think, if you're retraining frequently, if you're doing online learning, that's definitely a great step. But in my opinion, yeah, I think we should definitely use drift detection, even if we're doing that.
Great. Well, thank you so much again, Adam. And I know that you're over on the Slack channel, so please do go over and engage, ask additional questions. And then we will see you at our next session coming up. We have Kit Nguyen, who is going to be talking about Introduction to ML Compilers. We will see you there. Thanks.
Thank you very much. Bye.